Sketch the graph of an example of the function f that satisfies all the given conditions. So we have to graph one function f that has these properties. Okay, so let's look at first the limit of the function when x approaches to 1 from left side goes to infinity. Whenever a function goes to plus infinity or negative infinity as x approaches to a number, then that is a vertical asymptote because the function goes to all the way to infinity or all the way to negative infinity. So 1 at 1, so x equals 1. Does not matter whether x goes from left or right, so we have a vertical asymptote here. So let me get that here. Okay, so we have a vertical asymptote at x equals 1, and then function goes to infinity when x approaches to 1 from left. So when x approaches to 1 from left, it goes to infinity. So I'm just going to point this and I'll connect this piece later. Okay, this for now I only know this part, and this is good. Let's move to the second condition. The limit of the function is negative infinity when x goes to 1 from right. Okay, same place, but when x goes to 1 from right side, the function goes to negative infinity, so it decreases without bound. So I'm just going to write this for now and I'll connect this later. This is good. Let's move to the third. So limit of the function equals negative 2 when x goes to negative infinity. When x approaches to positive infinity or negative infinity, and if the function goes to somewhere, so that's a horizontal asymptote. So we have horizontal asymptote at negative 2 when x goes to negative infinity. That means on the left. So negative 2 is here, so we have a horizontal asymptote. Okay? When x decreases without bound, the function goes to negative 2. So this is like connecting here, but we need to see others. Okay, look at here, f0 equals 0. The 0 0 is part of the graph, so the graph passes through the origin 0 x0. The function means y is also 0, so the graph must pass through here. So this is good. So this one eventually it goes to negative 2. This is the case, and here we have another horizontal asymptote. Limit of the function is 0 when x goes to infinity. So when x goes to infinity, the function goes to 0. So 0 means it can come from the top or from the bottom. Same thing here, but we have this already here, so we just connect and go to 0. So this is good. And this one is here, and it could come from the bottom, but something happening on the top. So, and we have to connect to 0. So this is like here going from the origin and increases without bound. Okay, and so this is one of many correct answers, by the way. That's number 4. Let's move to this last question on this page. Here we need to find the derivative of this function using the definition. Okay, definition means the derivative is given by the following: limit of fx plus h minus fx over h as h goes to 0. That is, let's do some work on side. So the function is given here. So this part is 3x squared minus 5x plus 2. So we always have to find what is f of x plus h. Okay, that can be challenging at times. So f of x plus h is replace x throughout by x plus h. So this is simply 3 quantity x plus h squared minus 5x plus h plus 2. Now let's simplify. So 3 times x plus h squared means we need to multiply x plus h by itself. So just FOIL x plus h times x plus h. Okay, you do the work. If you FOIL, you're going to get x squared plus 2xh plus h squared minus, you distribute 5 here, 5x minus 5h and plus 2. So when we come back here now, this we have limit of h going to 0, and the bottom has nothing, just h. On the top, f of x plus h, this is, we figured out here, by the way, we need to still distribute 3. So that is 3x squared plus 3 times 2, 6xh plus 3h squared minus 5x minus 5h plus 2. Okay, this is giant. So f of x plus h we worked out on the side, and we got this minus, so minus means we need to distribute, minus 1 minus fx, which is given here. So minus -1 we distribute here, so this is 3x squared, this negative makes this positive, plus 5x, and this negative makes this minus 2. Okay, we are supposed to put negative here and parentheses around fx, but I just want to skip one step, so I distributed -1. And once now we need to simplify the top and expect a lot of cancellations, because 3x squared positive, negative 3x squared, positive 2, negative 2, positive negative 5x, positive 5x. Okay, then look at these 3 terms. This 6xh plus 3h squared minus 5h, and we can clearly see h is common in all 3, so we can factor h out. So that leaves 6x plus 3h minus 5 all over h. Okay, then once we factor h out, then we can cancel, because h times everything. So we can cancel h, and in the next step we simply plug in h equals 0. So 6x plus 3 times 0, 0 minus 5, so 6x minus 5. Okay, that's the final answer.